Assalamu alaikum and good morning, everyone. I
Walaikum
believe
salam.
we can begin. All of us are here. So before beginning like today's class, let's talk about something. I want to take a quiz next week. Like I need to take two more quizzes, right? I have taken one already, given one assignment. I will give the deadline. Like keep this assignment handy because it can get you a lot of marks. So I want to take a quiz, inshallah, next week. Are people fine with it?
Yes, sir.
And the topic will be like functions and whatever I cover today or this week, basically, that are basics of pointers. Okay? Not too much in depth, just the basics of pointers. Okay, and one more thing, like the Maghrib is like getting closer, so getting earlier. So I want to take today's lab a bit earlier. I want to start it earlier so that I can finish it earlier. I do not want to take so much time in labs anymore. And today's lab is going to be a bit easy. So whoever you like, those of you who have lab today, 1A. So do you mind if we start it a little bit early, like at 2:45?
Sir, at
No, sir.
3 would be fine.
It would be
Sorry?
fine, sir.
It would be fine,
Three.
sir.
Okay, so you people are fine with 3, right?
Yes, sir.
Yes,
Yes, sir.
Okay, then we can begin at 3 and we can end by like 5:45 or like, yeah, 5:30 or 5:45, inshallah. So we will begin our today's lab at 3. Okay, anyways.
Okay, sir.
So let's begin our today's class. So it will be a bit different. So do you have you guys like your pens and paper ready, because you should be taking a bit of notes today, okay? Because it's today's class is on pointers.
Yes, sir. We have.
Yes, sir.
I'll start recording. Is my screen visible?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. And whatever am I drawing? Is it visible?
Yes,
Yes,
sir.
sir.
Yes, sir.
So, just a moment. Okay. Today's topic is about pointers. Okay. Pointers, basically basics of pointers in C. Now, pointers are like a quite like fearsome topic to some people in C. People are afraid of pointers. Like, what are they? How to do it? Like, how do I handle so many indirections and things like that? However, if like this is a really powerful thing, actually, pointers. Once you know how to use it and once you get comfortable with it, it's not actually difficult. It's pretty simple. It's just like indirections. I'll give you a couple of real life examples whenever I'm discussing it. So once you get comfortable with it, you will be using it a lot. And actually, whenever you move on to other languages, and if you're like really like comfortable with C, in other languages, when you do not find pointers, they might become a little bit of problem for you. You might find it a bit annoying. Like, why can't I use pointers? Like, they're efficient and I can do so many things with them. So anyways, before like going to what pointers are, like try to remember from that from that class the basic types. I wrote something. I'll like again tell it to you. Like, if I have a like main function like this, integer main, my handwriting is understandable, right?
Yes, sir.
Yes, sir.
So how like zoom, and how do I move? Let me find out how do you move this board. Sorry, doing it.
So you have to off the pen tool, then you can move.
I think I found it. I'm trying to move while using the like pen tool together. So there should be a control binding. Now I do not know how to do it. That's why I'm not being able to move it using it. But anyways, so let's say integer main void, and then I have something like I have declared of integer I. Then let's say I have declared a float, like float f, and I have done something. I will do something more with them later on, like some more things with them later on. But I have declared two things, integer I and a float f. Now, we also have declared their types, right? Like these are the types, integer and float, right? So why do we declare types? First of all, C is a statically typed language, okay? And one more thing, based on that type, their operations will depend on, like based on the types, the compiler will decide what to do with them, like how to convert them, or like whenever we add one integer with float, the compiler will decide what to do. Other than that, there is one more important thing that I actually mentioned earlier. Like basically, whenever we are declaring type, we are reserving some space in the memory for that specific type. And the type also tells you how the values are arranged within that memory, like how to read that from that memory, right? Do you people remember? Like in case of integer, generally they are like 32 bits. So, like in case of integer, they are generally like 32 bits, right? Integers are 32 bits. Floats are also 32 bits. Or we can write 4 bytes. Right? Do people remember?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
So whenever we say like this is 32, this is 32 bit, this is 32 bit, or this is like some byte. So what does it actually mean? Like going to struggle a lot, I think. Sharing, trying to move this thing. Anyway, so what does it actually mean? Like this one is 32 bit, this one is like 4 bit. So what does this thing actually mean? So if we take a look at our memory, like let's say this is a memory space. This thing is visible, right?
Yes, sir.
Yes, sir.
So let's say this is a chunk of memory, not the whole memory. Now, each of this chunk, like this is a chunk of memory, there are more on top, there are more on bottom. This chunk of memory is actually like 8 bits. These are the 8 bits which can hold values, okay? So this chunk of memory is 8 bits. This one is also divided into 8 bits. And this whole thing is actually 1 byte. So what happens whenever we are storing like this integer value I? So this whole space in the memory is occupied the value of I. So what does it mean? Like it will have, let's say, I is equal to, let's say for a simple value, 3. I is 3. So what will happen? We know that like this one is 3, like 0, 1 and 2, 3, and all of them, rest of them are filled with zeros. And there are many ways values can be laid out in the memory. You will learn about them later on. So what will happen? The memory will be filled like this for the value of I. And there are more memory space on top and more memory space in the bottom. Sorry. More memory space on the top and more memory space in the bottom. So I figured out, I checked out a lot of things with Microsoft Whiteboard, except moving the screen. Very good. Good job, me. Okay, anyways, so these are how the values are occupying the memory. Now, the question is, they are somewhere in the memory, right? But the compiler or the program, whenever it runs, it fetches that value back, right? So it somehow gets back that value from the memory. Now, there should be some way to find out where that value is in the memory, right? Otherwise, we cannot get it back. Like if I put something somewhere, like I have a box, I have put it in your house. Like you need to have a location, right? Where I have put that in your house. Like I have put that on top of your reading table in your house, in your room. Once you know that, you can go there and fetch that box back. So similarly, whenever we're putting the values or storing them in our memory, there needs to be a location where we are storing it. And those things are called actually memory addresses. You see, like generally memories are divided into bytes. You can address 1 byte at a time. So what will happen? Like those actually have some kind of memory value. So these are like arbitrary values. These are like memory addresses that I'm just giving, like 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, and it will continue upwards, it will continue downwards. So these are basically the addresses of each of these locations. Remember, these are addresses. Okay? So these are the addresses of this location. And now if I ask you, what is the address of this integer I? What will be the answer?
Sir, from
2004 to
2007.
2007.
Okay, so from 2004 to 2007 is your answer. This is the address of this integer I. But one more thing, you know that in a system the size of an integer is fixed, and we can say that this is like 32 bits, right? Or 4
Yes.
bytes. So
Yes.
you already know that it will occupy 4 slots, right?
Yes, sir.
Because the size is 4 bytes. Since the size is 4 bytes, it will definitely occupy 4 slots. 1, 2, 3, 4. Now, if you know 4 slots, does only having the value 2004 enough for you to locate it?
Yes, sir.
Yes, you know that
Yes, sir.
the integer will take 4 bytes. So, and the integer starts as 2004 and 2004, 5, 6, and 7. These are the places where that whole integer is located, right? Because it is a 4 byte thing. Similarly, in case of float, like let's say, I'll clean it up. I have an integer I and I have a float f. So integer I was located from here, like I. These 4 slots are taken by integer I. Similarly, what can happen, like if I have like another slot here, let's say 2000, my float can be stored here, like this is float, and this floats. So these 3 values are occupied by the float, and these 4 values are occupied by the these 4 slots are occupied by the integer. Whenever I ask, both of them are actually 32-bit, right? Generally 32-bit, 32-bit. So if I ask you, what is the address of float f, what will you answer me?
2000.
2000.
Exactly. So let's say for now, address of f is 2000 and address of I is 2004. Okay, so these are the places, like these addresses, just like you have some address, where do you live? I live at that place, I live at Dhanmondi, I live at Mirpur, I live at Mohammadpur, or I live at IoT dorm. So wherever you reside, that place, like these addresses are basically those kind of location in the memory where we can locate that exact variable. Now we can actually find these addresses in our program. Let's take a look at an example. So let's say integer I, and I give I a value, any value. Let's say I is equal to 10. I is equal to 10. And sorry, I'm also in a bit of a mess of a wire right now. I need to fix it up properly. Anyway, so let's print out both the values and the address of the variable I. Let's print out the address first. And to print address, we use the formatted specifier or conversion specification of %p. And I put address, and let's print out the value. Value is equal to %t definition. And to get the address, can anybody tell me what do we need to use? We need to use an operator. Anyone? This is a familiar one.
N%.
Yes, exactly. We need to use the ampersand sign. We have used it a lot in case of the scanf function. We didn't know what it did. We will know for sure, or we'll exactly know in the next class what it actually does whenever we're talking about passing pointers to functions as arguments. So anyways, so remember, whenever we put the ampersand sign, this is a unary operator, right, associative, before a variable, Whenever we put those kind of signs, it means that we are now fetching the address instead of the value. Okay, address P and value. And if we compile and run the code, you see, like the addresses are really huge because the memory has a lot of locations. So this is the address, like this is a hexadecimal number. That's why it also has ABCDEF in it, and the value is 10. So this address is that 2004 that I had shown you before, and the value is 10. So is this clear to all of you? The address of a variable, and that we can
Yes, sir.
get it. Okay.
Yes, sir.
So
Yes, sir.
as we gradually move on, you'll understand why these address are important. Now, let's come to today's topics, which is pointers. Okay. So what are pointers?
Sir, I had a question in this slide.
Sure. This is not a
Sir,
slide, this is a board. Yeah.
when you ask what is the address of float, should we say that the address is only 2000 or it will be 2002 to 2003?
So the thing is, float is physically occupying the address value 2001, 2002, 2000, 2001, 2002, and 2003, right? But we also know that the float in a system generally, like in my case, even in my system, it is 32-bit, right? Or 4 bytes, right? So
Yes, sir.
if this value is fixed, do we need the range? We do not, right? Having just the starting point is enough for us, right?
Okay, sir.
Yeah, so we'll also come to that. The compiler automatically calculates all these things. Like it knows 4 bytes. So there are pointer arithmetics, which we'll learn next week. And then you will see like the compiler can decide all those things by itself, lessening your load of work. You just need to know the starting point. Okay? So starting point of a variable is enough knowing. So this is like the address and these are the values. And today we are talking about pointers. The question is, what are pointers, right? So basically pointers are a spatial type to hold object addresses. So this is a spatial data type in C. Pointers are spatial data type in C, even in C++, which actually holds object addresses. So I have already shown you what are addresses, right? These are addresses. We can hold them, and it is a special type of like variable or a special data type. You can say that to hold. One more thing you need to be careful about. I have said object addresses, not variable addresses. Why? Because as you would see, pointers can hold variable addresses. Whenever we go on and make structures and unions, we'll take a look at them like next week. So you'll see that any kind of address, you can hold them using pointers. Anything that resides in the memory. Anything that resides in the memory. What resides in the memory? Our code and our variables. Remember these two things. Our code resides in the memory. Our variable resides in the memory. Whenever we want to run a piece of code, it is basically loaded into your memory, in your case, RAM. And from there, it is run. And all the necessary variables, those are also loaded in your memory. So whenever we want to run, both codes or variables reside in the memory, and we can use pointers to point to both variables and codes. So pointing to codes, which are basically function pointers, we will take a look at them later. For now, our concern is just with the variable. So pointers are a special type of variables that hold object addresses. Okay. Now, why do we use pointers? Why do we use pointers? I didn't see this point in the book. I don't know why didn't they write it. So be careful about this part. Why do we use pointers? There are many use cases of pointers, but the main ones actually are, okay, basically heap memory allocation, So allocating memory in the heap, we will take a look at it in the second semester. Okay, whenever we're dealing with dynamic memory allocation, linked list, things like that, we will deal with this one. Okay, so this one is pending for later. It's used for heap memory allocation. Pointer is used to iterate through arrays, actually not arrays, any contiguous memory location. This thing we will take a look at in the next week's class. Iterate through arrays. Then pointers are like basically used to avoid copying large objects, basically kind of like passing memory address through functions. Okay, so this can be used to like avoid excessive copying, and it can also be used to return multiple things. So we will take a look at these things in tomorrow's class, like next class, not next week, next class, right away. And there is one final thing, basically, which is for functional programming or function pointers or pointers to code. Whenever I write PTRs mean pointers. Okay, so these are the basic uses or usage of pointers. For dynamic memory allocation or heap memory allocation, pointers are used also to iterate through arrays, which we will take a look at next week. And pointers are used to pass like memory addresses within functions instead of like passing the whole values. Actually, there are two things that it achieves. It avoids copying. We can return multiple things, and also we can modify the things in place to reflect the changes. Remember, like in case of array, I said, even if you pass an array inside a function and then you change the element values of that array, the change will be reflected into the actual function, because actually in those cases pointers were being passed. We'll take a look at them. That's why we can modify them in place. So, and also there's something called function pointers, which are basically a pointer to code, a piece of code. Like this is a function. We can even pass functions as arguments in code. So these are the uses of pointers. Okay, remember this one: iterate, passing, and function pointers. What happens whenever you come to any like this particular to remember? Whenever you go to any high-level languages like C++ or C# or Java, any other languages, what happens based on these basic concepts? These are basic concepts of programming. Based on these basic concepts, they build constructs around them. Like heap memory allocation, like in high-level programming languages, you do not need to worry about this. In case of C++, you need to do it manually. Okay, anyways. Most high-level languages have something called iterator or enumerator in some cases, which allows you to automatically iterate through arrays. And then they have automatically reference passing and things like that to avoid these things. And about function pointers, other languages have like functors, then function objects or delegates or other things to deal those kind of things. So what happens? C is a raw language, is a low-level language. You need to do things manually. That's why you learn it here in the first semester, so that you can know the concepts better from low-level perspective. And once you know that and you move on to high-level languages, you will know that they have used some kind of abstraction around them, build something around these things to make the things easier for you. Okay. Even C++ builds a lot of things around all of these. Okay, so yeah, is it understandable till now? Did you people get it? Like I haven't still showed you using pointers, but did you understand what are memory addresses and why do you use pointers?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now let's move on and try to declare our first pointer. Okay. We want to declare a pointer, and it is pretty simple. We declare pointer by assigning an asterisk symbol before a declared variable. Like if we want to declare an integer pointer, remember, we need to declare their type. We want to declare an integer pointer. What we'll do, integer pointer, and let's call it p. As simple as this. This is a pointer variable. So why do you put this sign? Conventionally, this sign is put right before the identifier of that variable or the name of that variable. But if you want, you can put it here, or you can put a space. Like if I want to show you inside my IDE, inside my code, what we can do. Like integer pointer p. This is a fine declaration pointer. This is a fine declaration, and this is also fine. Okay, so generally it is declared this way. Okay, integer pointer p, and we can also declare like all of them together at all again, like integer, then pointer p, and I want to declare an array with 10 values. We can declare all of them together if you want. Okay, all of these are fine. I have declared an integer pointer, and then an array of integers with like length 10. Okay, so we have declared an integer like this. And if you want to remember, the type matters. If you have a double and want to declare a, like if you have a double D and declare a pointer to that, so we should write double pointers, let's say p underscore D. Okay, so pointers are associated with types. Remember, I've said, or we have already discussed, like each of the different data type have occupies different sizes in the memory. And whenever we are printing the addresses, we are only concerned with the very first value. So how do we know how much memory space they occupy? From their type. That's why for each of the different pointers or each of the different type, even for custom types, you can have their pointers, and declaring pointer is easy. Just before the name of that variable while declaring, there is another use of this operator. Okay, so remember, whenever we are declaring, if we put a asterisk symbol, that means it's a pointer. Okay. Now,
excuse me, sir.
yes, sure.
Sir, is it mandatory to put an asterisk, or is it just a convention?
Oh, this is a different type, so you should put an asterisk. The thing is that this is a huge integer, right? The address is basically a huge integer. Now you can take a long and put the address in there. That is fine, but you are in that case treating it as a numerical value. But whenever we're declaring with this one, like asterisk, this asterisk is not part of the identifier. The identifier is just PD. Okay, the identifier is just PD. If you take a look at it, the asterisk is actually part of the data type. So when I was like used to be of your age a little, I used to, even sometimes right now, I declare my pointers like this to like enforce the fact that, okay, this is the data type, like double pointer is the data type and PD is the identifier. But the convention is actually basically declaring the asterisk value with the identifier. That means PD is a pointer, P underscore D is a pointer, it is a double pointer, okay? And this is an integer pointer, okay? So so we need to put the asterisk. Now, they not only hold the address values, sorry, there's a lot of noise going on in the background. So they not only hold the address values, we can also perform some operations with them. Okay, that's why pointers are treated as different data type. We'll take a look at them later. Pointers have some operations, they have some extra operators that they support. Whenever we talk about like structures and unions, we will see there. So they are different things, okay? So we need to put the asterisk to make it a pointer. Okay, so by default, if you like declare a variable, any type of variable, they will hold what kind of value? Anyone in C? If you just declare a variable, what value will it hold?
Garbage values.
Exactly. So even right now, whenever we have declared the pointer P, it holds garbage value, okay? So now we will actually look at two operators. One we have shown, and we have already shown, you're familiar with it. That is the address operator. Now, two more operators, okay? Two more operators, okay? The first one is called the address operator. And you have already seen the use of it, the ampersand symbol. That is fine. Ampersand, whenever you see ampersand, it means basically address. And another one, which is called the indirection or the dereference operator. Okay. And which is the asterisk symbol. Not this asterisk symbol that you have already seen, not this one. Okay. We will talk about this asterisk symbol. Like we'll talk about this later on. Okay. Indirection or dereference. So these two are our focus for today's class. Okay, the address operator and the indirection or dereference operator. Let's come to the like easier thing first. Like, let's say I have an integer I and I have a pointer P. I want to use that pointer to hold the address of I. I can write P is equal to, can anybody tell what I can write to hold the address of I in P?
Ampersand I.
Exactly, ampersand I. Ampersand means give me the address, and this is the variable which I want the address of. So P is equal to ampersand I. Now what I can do, address percentage P, instead of writing ampersand I can directly write P here, because we know P now holds the address of I. And for now I'll use I, but there's also another way to fetch the value from P. I'll show it to you. Okay. So if we run this code, we see the address is being printed. Now the address will change. Okay? And also I didn't put any value of I should initialize it to, like I is equal to less than 99. Run it. Okay. The address is this. The address will be randomly assigned when the program runs. So you can never be sure what the address will be. And the value is 99. Okay. This is the address. This is the value. So do people understand what the AND or ampersand operator is doing? It's taking the address and it is putting it in the variable P, which is actually a pointer, a special type of variable designed to hold addresses. That's why we directly are printing the address using P. And now let's come to the other thing, which is called the indirection or dereference operator. Now, we can basically write asterisk P instead of directly writing I. What does this asterisk symbol means? It means go to the address of P, go to the address that is stored in P and fetch me that value. Fetch me that value directly. So what does P hold? It holds the address of I, right? P holds the address of I, and I'm asking it to go to that address and fetch me the value directly. So what will the value of asterisk P be? I'll show you graphically, don't worry. So if I print it, it is directly 99. What is happening? So address is that one, and you're seeing that nothing has changed. Basically, address is being printed and the value of I is being printed. Okay, so let's see what is happening. We have two things. Integer I, and we have integer pointer P, right? We have integer I and integer pointer P. Let's say this is a memory location which holds the value of I. Now, what did we set the value of I to be? I is equal to 99, right?
Yes, sir.
And so this memory address holds the value 99. If I'm writing it with green, if I'm writing it with blue, that means it is an address. Let's say this address is, give me any value for this address. So let's say this one is 5,000. Let's say this address is 5050 in the memory. The value is 5050 of this address. This is the address. So I have declared a variable I, which is residing at the address 5050, and these are 4 slots. I've just written 99 for simplicity, and this is holding the value 99. Now I took a pointer, okay, and that pointer is P, right? And then I have said that P is equal to and I. What is happening whenever I am setting P is equal to and I? What value is P holding? P is holding the value 5050, right? This is what the address. Is it clear? Whenever I'm writing P is equal to and I, P is now holding the address 5050, right?
Yes, sir.
Yes, sir.
So that is holding the address of I. It basically means P is now pointing to this variable I. Okay. So what happens when we write ampersand P? Sorry, asterisk P. Writing asterisk P basically means go to the address stored in P and get the value. Basically, this can put get or set. So now tell me, go to the address stored in P. Now, what is the address stored in P? 5050, right?
Yes, sir.
This is the address stored in P. Go there. So I'm going there. Okay. And what is the value stored there?
99.
99, right? Okay. So what is happening whenever I'm writing asterisk P? It basically means, okay, so P has an address. I go to that address and take the value. So basically writing asterisk P is an alias for writing directly I. Okay, so these things are, you can consider them equivalent. Whatever you can do with I, you can do with asterisk P, as long as you have assigned the address of I to P. Like instead of like now directly working with the value I can use this indirection that P points to I. So wherever P points, I can utilize that value to deal with anything related to I. So I can actually change the value afterwards. What will happen? Like see, P is equal to and I. P now holds the address of I. Okay, so now if I change something like this, I is equal to 200, and then again print out this value. Can anybody tell me what will be the output of this program if I write it like this?
Sir, 200.
In the second case, it will be 200, right? So address, we do not know. It will have some address. Let's say for now, like 50-50. And this value will be 99 in the first case, right?
Yes, sir.
Okay. And then we have set I equal to 200. This address will again be 50-50, like hypothetically speaking. If the first one was 50-50, the second one will be exactly same. The address will not change. However, if you write the value again, what will be the value? We have changed I, but we are trying to print asterisk P. What will be the value?
200.
Yes,
200.
200. Because, and we write, okay, the address was, see, the address is same in both cases. The value was first 99, then 200. And if we again actually directly print the value of I, okay, so what we can do, we can directly print the value of I, and then ampersand I, which is the address. So the first two, these two lines should print the exactly same things, right? The first case, I'm directly printing the value of I. Sorry, I've written it in a reverse order. And I. So first case, we are printing the value, the address of I, and directly the value of I. And now we know that P is binded to I by writing P is equal to and I. P is holding the address of I. Now we are directly printing the P, which is an address directly, and then an indirection of P, which will point me to the value of I directly. And then I'm changing I is equal to 200. I'm doing it again. And let's do one more thing. Asterisk P is equal to 500. And let's print out the value and location of I again, not P. So if you compile and run it, okay, like as if we are just modifying one thing, the I value. Okay. In the first case, we are printing the address of I and then I. The address of I, it is fine. And the value of I, which we initialize to 99, it is fine. Now, remember, we have set P to point to I. Okay, P is equal to and I. P holds the memory address of I. Now, if we print directly the value of P, which holds the memory address, and then in direction of P, what will it print? It will print the address of P, address that P holds, and the value at the address that P holds. And the value at the address that P holds is basically the value of I. That's why it is 99. Then I'm writing I is equal to 200. Change the value of I to 200. Then I'm printing P and the indirection of P again, which is printing the address again, and then the value that was being stored in the address pointed by P. And again, now instead of directly changing the value of I, I'm saying go to the address of P and change that value. And I'm changing that value to 500. Now, if I print the value of I again, the address of I and value of I, it is being printed as 500. So if I want to clarify this whole thing, so we have created a relationship like this. So this is the variable I. These are the pointer P. And whenever I'm writing P is equal to and I, what I'm doing, I'm creating an indirection. Okay. So this basically holds the address of P. This holds the address of I, right? This holds the address of I. And this is the whole system that I'm now dealing with by writing P is equal to and I. So whenever I'm writing like, okay, instead of setting I is equal to 99, I is equal to 200. Now what is happening? This 99 is being replaced with the value 200. Now again, if I ask you, like I wrote I is equal to 200, then I ask you what is the value of in direction of P. In direction of P means go to that address and fetch the value. If you go to that address, what value you will get?
200.
200, right, correctly. So, and again, like, okay, instead of doing this, what I am now saying, I'm writing, okay, P is equal to 500. So what does it mean? Go to the address that is stored in P and set that value to 500. It can be used as both L value and R value. You can use it in the left side of the equation or in the right side of the equation. It doesn't matter. You can fetch the value or you can set the value, just like any variable. Like go to the address of P and set the value to be 500. If I say that, now what will happen? This is P, address of P, it basically holds the address of I. I'm setting the value to be 500. Now, if I ask you what is the value of I, what will it be? 500, right?
500.
500. So by changing I or by changing asterisk P, we are basically changing the same thing, right? Because asterisk P points to I. So if P points to I, by going inside the address of P, if I change that value, it means basically changing the value of I. Is it clear?
But sir, while we were changing the value of I, why were not the address were changing?
So this is what we are changing, right? This one is 500. And then I'm writing like, if I write I is equal to 2, I has changed, right? The value of I that is holding has changed, right?
Yes,
But
sir.
have I moved this box anywhere? Have this box gone anywhere? Like this box has a value, location, right? Consider it this way, like you have a plate in your table, dining table. I can put different food on it, right? Like
Yes, sir.
you have a plate in your table, you're not moving the plate. Okay. So I is basically that plate. I is that plate. I can put different foods on it. I can put biscuits, I can put chips, I can put rice. Okay, I can put chicken, I can put whatever I like from that plate. I can clean it up, I can put different things. Is the plate moving?
No, sir.
Okay. If I ask someone like, okay, go to the dining table, take that plate. Okay, that plate that is maybe like situated in the left corner of the dining table. Go to that plate in the left corner of the dining table and tell me whatever you see there. If I ask that, if I tell you that, now, is that plate moving? No, right? That plate is at the left corner of the dining table. Like if this is your dining table and this is where your plate is at, this plate is similar. Now I can put different items here. I can put like a red colored food, blue colored food, or a green colored food here. And you as an observer, I just asked you to go to your dining table and tell me whatever you see inside that plate. Now, if I ask put a green colored food there, you'll go there and find green colored food, right?
Yes, sir.
Okay, and if I put blue colored food, you'll go and find blue colored food. Is the position of the plate changing?
No, sir.
Okay, so that is the address of the plate, right?
Yes, sir.
So address doesn't change. Address of a variable does not change.
Okay,
Whenever
sir.
a program is running, the address of a variable is not changing. Whatever that variable is holding, whatever value that variable is holding, we can change that, but not the address. Got it?
Yes, sir.
So see, since that address is kind of a static thing, we can use a pointer to point to hold that address, and using that address, we can basically go and modify things. Like I has the address 5050. By writing asterisk P equal to some value, or by writing print the value of asterisk P, what we're doing, we're saying that, okay, go to that address, whatever you see, either modify that, or whatever you see, print that out, or use that to do some kind of mathematics. Okay.
Sir,
Yes.
as pointer pick holding the address of I, does that mean it is consuming more memory?
Yes, exactly. So pointer itself is a variable, right? Like
Yes,
if
sir.
you take a look at this structure, like this one is like kind of similar, right? This one, P has a box, I has a box, the box of I has some value, the box of P also has some value, which is the value of I, right? The address of I, right? Like
Yes,
this one holds the value 5050 here actually. If 5050 the address of I. Actually, the pointer P itself also has some memory address. It can be like 100020. It can be something like this. The pointer P also has some memory address. Okay, because it is just like any other memory. Like P is a pointer, right? But if I ask it, okay, address of the pointer. and I want to print the address of the pointer. And how do we get the address of any variable?
Put an asterisk and
Ampersand.
and
Put an ampersand sign. And if we put an ampersand sign before P, now we're asking the system, give me the address of the pointer itself, not the value which the pointer is pointing to. And if we print that, now see, this address is different from this one. Like this ends at 7B8, and these are all 7C0. Okay, so you see, the pointer itself is like a normal variable. It has some address, and it holds some other address in it. Okay, so pointers are just like any other variables. So as a result, we'll take a look at later, you can also have pointers to pointers as well.
Sir, if we don't store the address and just print the address directly using and I, won't it consume less memory without using?
Like this is a small amount of memory. Whenever you actually see, like let's say, should I give this? Like, yeah, this is using extra memory, like holding P, like holding this value inside P, we have declared another variable. And since my operating system is 64-bit, generally like your pointer size depends on your program, or like is it a 32-bit program or 64-bit program and your operating system. Since our operating systems in most cases are 64-bit, pointer consumes 64-bit of memory. So we are using that 64-bit of memory to hold the value of I. Now, like instead of just using variables, let's say we have an image. Image are basically 3D arrays. Okay, I'll take the question, don't worry. Images are basically like this is basically one, or should make it four. Like this is actually a 1080p image that you people generally use. Like this is a huge amount of memory, right? Now this will take like couple of megabytes. However, if I declare a pointer to it, which will be the very first location actually of the starting point of this image, we'll take a look at them later whenever we are dealing with like arrays with pointer. That pointer is pointing to basically the initial or starting position of that image. Again, the pointer is 64-bit. However, this variable itself, like this array, is actually huge, really, really huge in size. It's in megabyte length. And I have a 64-bit pointer to it. And what I can do, instead of passing this whole image around, like, you know, like whenever we pass something, things get copied around. Instead of passing this image around, we can pass the pointer around. Like, this is the address, go there. This is the address, go there. Like, instead of moving the whole thing completely again and again, we can use the pointer to move a reference to that thing. Okay, which saves a lot of memory. Like, so this though, like in simple cases, only consumes, like, you may think that, okay, this is consuming extra memory, but in the real cases where pointers are used, that much memory saves up a lot of memory in the long run. Okay, so anybody raised their hand or had a question?
Sir,
Thanks,
in your
yes?
code in line then and the asterisk in line 5 is different from all other asterisks.
Exactly.
I mean, the significance.
Exactly. So this is a like bit confusing, but whenever you are declaring a pointer, to declare the data type, we use asterisk, and whenever we use them later on inside our code with anything, it basically means in direction. Okay, like go to that address and do those things. But this asterisk is different. It is used to initialize the variable as a pointer. Okay.
Okay, sir.
This initialize the variable as a pointer, and whenever you're using this is basically, okay, go there, paste the value, and do some things with that. Okay, so
Sir,
yes,
sir, as P is a variable and its data type is integer.
Its data type is not integer. Its data type is integer pointer.
Okay, sir, integer pointer. So then does overflow happen here? Overflow of as the memory address is quite big.
Like, pointers are designed to hold all the possible memory addresses in your computer, right? That's how pointers are designed. As I have said, you have a 64-bit operating system, you'll get a 64-bit pointer if you write pointer. If you have a 32-bit operating system or 32-bit code, you'll get a 32-bit pointer. The pointers are designed to hold all the possible memory addresses that your computer can have.
Okay, sir, I got it.
So
yes,
generally overflow will not happen, but in some cases it might. Why? Whenever you're doing some arithmetics with the pointer, there are chances, but those are really rare. They generally doesn't happen because pointers are designed that way. Okay, Fahim Abrar, yes?
Assalamualaikum, sir.
Walaikum assalam. Yes.
Sir, if we need two pointer, then do we need to write int star p star q or int star pq?
Star P, star Q, like I have already shown you, like you can declare things together, right? Okay, so
Yes, sir.
if you want another pointer, you need to write it like asterisk Q. If you just write Q, it means Q is a pointer itself. Sorry, Q is a normal integer itself. See, integer Q, but P is integer pointer P. So if you want multiple pointers, you need to write the asterisk symbol before each of the identifiers. That's why this asterisk is put before the identifiers. Okay.
Okay, sir. Sir, yeah. Do pointer have any data type, or pointer is itself a data type?
Itself is a data type. Integer pointer is a data type. Double pointer is a data type. Character pointer is a data type. Like this is the data type. Character pointer. This is the data type. Okay? Or whenever you feel like integer pointer. This is the data type. Okay.
Okay, sir.
If you want to, like, there is a small trick. Like I have talked about type def, right? So what we can do, like this thing that will not work with macros, but with type def is we can write integer pointer as a new type called intptr. And now if we declare them like intptr p, okay, they have already declared it by default, like p and q. Now, actually, both of them are integer pointer. P and q, both of them are actually integer pointer. So yeah, that's the specialty of type def. But if you're not using type def, we need to mention, or we need to like say that each of them are actually pointer by themselves. We need to stick the symbol before that one. Okay.
Yes, sir. I understand.
So remember,
Type def outside
Sorry?
the function. Sir,
Can
can we actually use type def inside the function?
yeah, it should work.
Yes, sir.
Yeah. But now this type def things is only available inside this main function. If you have another function, you will not find that type def there. Okay.
Yes, sir. Understood, sir.
So we
Sir,
can
I
use
have a
type def.
question, sir.
Yeah, go on.
So since integer pointer and float pointers are different variables, what happens if we typecast an integer to a float?
It will be integer to a float.
Yes, sir.
So
And-
whenever you are like that value is now like, to use pointers, you need some variables, right? So if I just write like okay, float 98, like, can we use a pointer to them? We can use it like this. Like, let's say we declare a variable float f. We haven't assigned the value, and now we define a like float pointer like p underscore f, and then what we can do, we can write in direction of p underscore f equal to float of 98. This will work fine. Okay, we are converting an integer value and holding it there. However, like we cannot write like directly write the p underscore f is equal to 98. This doesn't work because this is a floating point value and this is a floating point pointer. The values do not match. And without declaring, like also like before doing this thing, like p underscore f, we actually need to bind p underscore f to something. Like p underscore f is equal to and f. This thing is necessary before you do this one. Why is it necessary? Why is it necessary? If you do not write this line, now whenever you initialize p underscore f, what value does it have? Garbage value, right? Garbage value. It is pointing to a memory location which you have not reserved yet, right?
Yes,
Which
sir.
you most probably have not reserved yet. Now, if you try to write in that location, this is a violation, right?
Yes, sir.
You're trying to write some value to whatever location p underscore f is pointing at. Now, that location you do not know. You haven't reserved it yet. This is not a location that belongs to your code. So these kind of things, like without initializing a pointer to some other variable or some dynamically allocated memory, which we will take a look at later, like without initializing them to some memory location, if you try to write it, it will cause some runtime error. Okay, the program can crash, the program can ignore it, might work, it might not. The operating system might cache things. So yeah, so remember, whenever you are using a pointer, it should be binded to a variable. Of course, you can have like f1, f2, and doing something like f1 and let's say f and f2. Now p underscore f is equal to float 98. What will be the value of f now? Writing these 4 lines, what will be the value of f?
So 98.
Exactly, 98. But if I 98, right? If I write p underscore f is equal to and f2 and then I write like asterisk p underscore f is equal to 101.5 f. Okay. Now what will be the value of f now?
So 101.5.
No, the value of
No,
f
sir,
is 98.
is unchanged.
Remember line number 15. Now we have changed the value of the pointer, and now we are saying that it is no longer pointing to f, it is now pointing to f2. And when I write asterisk p underscore f is equal to 101.5 f, it now means, okay, instead of changing the value of f, since p underscore f is now pointing to f2, go and change the value of f2. If we want to visualize it, so we have a float pointer like this. So this is p underscore f. And now we have two variables. Okay, this one is called like f, and this one is called f2. In the very first line, we have said that p underscore f is equal to and f. Now what is happening? Now this thing is pointing to f, right? And then we are saying that, okay, asterisk p underscore f is equal to 98 or float 98. Then what is happening? We're saying that, okay, go to whatever pointing p underscore, whatever location p underscore f is pointing at. P underscore f is pointing at f, and change that value to 98. So 98.0 f. Okay. Then we're again writing p underscore f is equal to and f2. Now what is happening? Instead of this indirection, we are now removing this indirection. Okay. We are now removing this indirection and saying that, okay, p underscore f now points to f2. No more f. Okay, by writing this line. And then we're saying, okay, p underscore f is equal to 101.05 f. So go to that location. Now p underscore f is pointing to f2, no more f. So we're going to that location and sending this value to 101.05 f. Understood?
Yes, sir.
So at different times, a single pointer can point to different things. And also remember, do not use pointers without initializing them, okay? Without allocating a memory address to them, Without properly allocating a memory address to them, do not use them. Or do not use the indirection. It will cause garbage value. Similarly, remember one thing. Multiple pointer can point to the same thing. Like I can have integer, let's say I, pointer p, pointer q, and also have another pointer r. I can write p is equal to and I. Now the pointer p holds the address of I, right? Okay. I can write q is equal to p. Q is a pointer, right? A variable designed to hold addresses. P is a pointer, a variable designed to hold addresses. It has the address of Ri. Now I'm saying q is equal to p. Whenever we directly write p, remember, like whenever we directly write p, we directly get the value of I. That means writing p is equivalent to writing and I. So whenever we write that, like q is equal to p, what is happening? The address stored in p is getting copied to the address stored in q. So what was the address stored in p? It was the address of I, right?
Yes, sir.
So q now also holds the address of I. And we can again write r is equal to and I. Sorry, let's just do some, yeah, r is equal to and I. So r also have the value of I. So what is happening here? This is I. First, like this is the variable p, and then we're setting p is equal to and I. That means p is now pointing to I, right? Next line, q is equal to p. We have this value q, and this value we're asking copy the value from here to here, which means q is also now pointing to I. Then we're writing r is equal to and I. So we're taking like another pointer and r is equal to and I and manually setting it to the pointer. Now all of these like p, q, r currently pointing to I. So if I change I is equal to 10, this value will change to 10. If I write asterisk p is equal to 20, this value will change to 20. If I write asterisk q is equal to 300, this value will change to 300. If I write asterisk r is equal to like 1000 via this indirection, this value will change to 1000. Get it? You can have multiple pointers pointing to the same variable at the same time. It is completely fine. And by changing the indirection through any of them, we can change the value of the original variable. Understandable?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So one more thing, like some nonsense thing. I write something like this: asterisk and I. What does it mean?
When I'm
Sorry.
assigning ampersand I in
Okay. So okay, this is simple.
So that is the memory address of
the
P.
address of I is coming
This is exactly
in P,
equivalent to I.
right, sir?
Tanvir, your voice get cut off. Sorry if I'm taking your question. Tanvir, please repeat your question again. Tanvir?
So ampersand I is when assigned in P, then the address of I is coming at the
Pointer P, yes. Tanvir, I think you have some internet issue because Tanvir? Okay, Tanvir, ask your question a bit later. Okay, I think you're facing some issues. Zarif, what question did you have?
maybe the fellow.
Sorry? Zarif?
Sir, is it possible to create a pointer for another pointer?
Yes, yes. Like this is a pointer, right? Integer pointer. We want to create a pointer that points to P. We can write integer pointer, let's say PP. So what is happening? We can write things like P is equal to and I, and PP is equal to and P. So what is happening here? If we take a look at here, like this is PP, this is pointing to like another thing, which is P, which is pointing to another variable, which is I. Okay.
So it's still gonna take the integer type, even though P is not itself an integer.
P is holding the address of an integer type, and PP is holding the address of an integer pointer type. Remember, two asterisk symbols.
Okay.
Pointer to integer pointer. We'll discuss about integer pointer to pointer later. Okay, we will discuss about them. Don't worry about them. Even if
So
not in this semester. Yes.
Can we say PP equal and I?
Yes, you can write that. No. You can't write that. No, you can't write that because like and I is the address of I, and the address. This is now a directly raw value. This isn't stored anywhere. Whenever you're writing P is equal to and I, now this is stored in a variable which has an address. Like if you write and I, does it make any sense? It doesn't make any sense, right? This is a raw value. Like this is a static number, right? That you have fetched and I, and that doesn't have any memory address. You just now have it cached in your hand. You do not have any specific value. You need to store it in a pointer first, and then you can indirect it. Remember, pointers always need to point to something, to some variable. Pointers by themselves are not sufficient enough. Pointers will always point to some other variables or some dynamically allocated memory. Okay?
Oh, yes, sir.
So they always need to point to some other kind of variable. Okay, so about this thing, like asterisk and I, what does it mean? First of all, and I means the memory address of I, and then I'm putting an asterisk symbol before, which basically says go to that memory address and fetch the value, which is basically just I itself. Is it understandable why asterisk and I is equivalent to I?
Yes, sir.
Can you repeat it again?
Let me clear up everything. Sorry. So, like this is the variable I, right? This is the variable I. It holds some value, let's say an address of 2004, and it holds a value of 50. Whatever is outside this box is the address, and whatever is inside this box is basically the value. Now, whenever I write I inside the equation, like let's say print I. That's the command I've given. Print using printf. We have written other things. Print I. Basically, it means print 50. Okay. Now I have written print and I. And I means the address location of I, which is 2004. Now, if I write asterisk and I, what I am saying, go to that address location 2004, go to that address location 2004 and bring whatever value is there, which is again 50, right? The indirection operator, go to that address location and get me the value. That's what indirection operator does. This is indirection operator, not pointer, like not declaring pointer. So if I write something like this, I is 50 and I is 2004, and asterisk and I is again directly the value 50. Got it?
Yes, sir.
Can we put another and before it?
Yes,
Yes,
sir.
sir.
No, the answer is no. No, because I was a variable. I was a variable. This asterisk and I is not a variable. Asterisk and I is directly the raw value 50. And I cannot put address symbol before the value 50 because 50 is not a variable. Okay, we can only put the address symbol before a variable. Like it has already been resolved to a direct numerical value. Just like writing I plus plus, then plus plus again. This is not valid, right? Because if I was 2, I plus plus would made it like 3. Now, plus plus was incrementing the value of the variable I. But like since I have written plus plus already, this has now been resolved to a constant value 3. And I cannot like use the plus plus operator with a constant value. The plus plus operator must be used with a variable, because it changes, it goes to that variable and increments the value of that variable. 3 is not a variable. Similarly, here and I have, and then putting an asterisk before has already been resolved to the numerical value 50. I cannot put the ampersand sign before anymore. Okay. Remember that much. Like try to gradually solve things by things. Like asterisk symbol works with an address. Okay. Asterisk symbol takes an address as input as long as you give any address. Like somehow, if you know that, okay, my variable resides in a like address location like this. If you know that, in some cases, you know, wherever you're designing operating system, the very first things you actually manually put in the memory, and you know those addresses. Okay, so if you know the memory address, you can directly put an asterisk symbol before it. This is an memory address, and it will work just fine. The ampersand symbol takes a variable. Basically, this is an L value or object. That's why I write object. Like it will take an object as its operand. Okay, you cannot put a numerical value there. It needs to be like I, J, K, or some other variable that you have declared. For now, let's say variable. It needs to be some kind of variable you have declared. So remember this much: the asterisk symbol will take an address. An address is a numerical value, and the ampersand symbol will take an object or L value, like I, J, K, L, some other variable. So remember this much. This will help you. Understood?
Yes, sir.
Just let me check whether I have missed anything or not. And you have seen that there can be multiple indirection to the same thing. Multiple pointers can point to the same object, and we can change the value through any of them. Remember to initialize pointers before using them. Like do not like just go on like integer pointer p and indirection p is equal to 10. Do not do this thing directly without like doing something like p is equal to and I. Okay, and like though this is not generally done very commonly, but it can still be done. Like you can initialize a pointer, a variable, and like p is equal to and I. You can directly do it as long as I comes before p. Basically, you're saying integer I, declare an integer I. Then you're saying that okay, also declare an integer pointer p and bind the memory address location of I to p. So generally these are not done. Okay, like this will work. This will work just fine. But generally these are done in separate lines to make things clear. Okay, remember that much. And one more thing, like one final thing. Let's say I have integer variables, integer I, integer j, and I have 2 pointers, integer pointer p, integer pointer q. I'm binding P is equal to and I, and I'm binding Q is equal to and J. And let's say Q is equal to 100. If I write asterisk P is equal to asterisk Q, and if I write P is equal to Q, what will be the differences between these two? Anyone? This is one thing, this is another. Anybody?
Sir, the first one is the value of I and J, and the second one is indicating the value of the memory address.
First case, if I write asterisk P is equal to asterisk Q, what is happening? Like, let's say, sorry, this should be like asterisk Q is equal to 100. Okay, so these are the execution order, like this one, and then either this one or that one. So asterisk Q is equal to 100. Now this one is I, this one is I, and this one is J. By writing, since I have bound the address to Q, asterisk Q is equal to 100, I have set the value of J to 100, right? This line, asterisk is equal to 100,
Yes, sir.
I have set to 100 here.
Yes, sir.
If I write asterisk P is equal to asterisk Q, this statement basically means whatever address that P is holding and modify that value to B. Go to the address, whatever address Q is holding, and fetch the value from there and put it there. So what's the value of asterisk Q? 100, right? J is holding 100, asterisk Q means the value of 100, and then I'm writing asterisk P is equal to asterisk Q. So doing this, we'll copy the value 100 to I. Since P is indirect pointing to I and Q is pointing to J. So whatever P is pointing to, set that value to whatever Q is pointing to. 100, I will be 100. Understood? This one?
Yes, sir.
Yes, sir.
However, instead of executing this line, if I write P is equal to Q, I will not be changed. Rather, the address of Q, the address that Q is holding will be copied to P. That means previously P was pointing to I and Q was pointing to J. If I, instead of executing this line, if I execute P is equal to Q, basically it will mean that, okay, so instead of execute, it will mean that now P no more points to I, P now points to J. If I write P is equal to Q. Understood?
Yes, sir.
So that's all for today's class. Anybody have any question?
Sir, in the next case, where 2p equals to q, just because
Not 2p is equal to 2. In the case number 2, p is equal to q.
Yes, sir. Where we have put the q equals to 100. Sorry, ampersand asterisk q. That's why that the p is indirecting the j equals to 100. Like, shouldn't we say that the q is also pointing at p I?
No. Q was pointing to like asterisk Q. What does it mean? Q was previously pointing to J, right?
Yes, sir.
Q was pointing to J. Now I have written asterisk Q. That means go to whatever place Q is pointing at and fetch me the value of there. So if you resolve this, go to whatever address that Q was pointing and fetch me the value from there. What will it be evaluated to? It will be evaluated to 100, right?
Yes, sir.
Okay. And by writing asterisk P, I'm saying go to whatever place P is pointing at and set that value. P was pointing to I, right?
Yes, sir.
So basically this statement is equivalent to writing I is equal to 100.
Okay, sir.
Understood?
Sir,
Yes.
can we just do some arithmetic calculations using these
We
pointers?
can do a lot of arithmetic calculations using pointers. That's the most powerful thing of pointers, but we'll take a look at them in the next week, okay?
Okay, sir.
Tomorrow's in next class, we'll take a look at how we can pass pointers to functions as arguments to like basically return multiple things or simulate that behavior, and how we can also return pointers from functions, okay? Those are for tomorrow's class. Any other question?
Sir, what will happen if we write P equal to asterisk Q?
Now this is like a bad thing. Like generally compiler will throw you an error, like throw you a warning. You are basically, so what is happening? P is equal to asterisk Q. Asterisk Q was 100, right? And now you're setting that this pointer P is pointing to the memory address location 100, which in most cases you haven't reserved, okay? Like have you reserved 100 for your program? memory location 100, like I can take a pointer, like this is exactly writing like integer pointer p, and p is equal to 100. We haven't reserved the memory address 100 yet. So if I write p is equal to 100, that will result in an undefined behavior. We can pick like what is there, but if we try to modify that value, we will get an error.
Okay, sir, got it.
We're just saying that p is now pointing to the static memory address 100. If we write something like p is equal to asterisk q, because q was pointing to j and the value of j is 100. So basically we are writing set the value of p to 100. P is a pointer variable. We are now saying, okay, so p now points to the address 100. Now, if we try to go to the address 100, we do not know what we will find there because we haven't reserved anything. Understood?
Yes, sir, got it, sir.
Any more question? So, like, I took to this class differently. There's no slide. That's why I ask you to take the note to yourselves. Remember that much. You will have the video. So, but I think to make you people understand pointers, especially pointers, like drawing things are necessary. So, was it fine by you guys?
Yes, sir.
Yes, sir, it was very good, sir.
Sorry?
Yes, sir. I think we like this method.
As long as it is necessary, I will take the classes this way. But remember, in those cases, you might not get the slides, so you need to take the notes yourselves. And remember, these are from chapter 11, I think. From, let me take a look. Yeah, these are from chapter 11 of KN Kings, okay? The basics to pointers. I haven't completed this chapter yet. There's like still 2 more sections left, like pointers as arguments and pointers as returns from functions. So after that, this chapter will be completed. So whenever you're free, like especially after this class is over, go through this chapter, okay? This thing is written really like in a simple way. So inshallah, you people will be able to understand. Okay, that's all. I'll stop the recording and take your attendance afterwards, okay? Also remember, your like lab today is at 3. Since only a few of you are present, a lot of you are absent today, so I'll take the attendance. Abu Hena Shadid? Give me a moment. Sharia Rashid Khan Sifat? Sharia Rashid Khan Sifat? Absent. Abu Jawad Muhammad Ridwan Hussain?
Present, sir.
Muhammad Arafat Hussain Amjar? Absent. Tausif Tashwar Dipto?
Present, sir.
Asif Abrar?
Present, sir.
Asif Mahmud Fahim? Asif Mahmud Fahim? Jarin Tasim Bidi?
Sir, Rule 7 won't to join any class for the next 1 month. He told me to let you know that.
Okay. Jarin Tasim Ridi. I'll be calling his name whenever I call, because like this is not an acceptable reason. Like he hasn't been struck off. Like I cannot just give him absence for 1 month. So I'll just call his name and he'll be absent. Okay. Fahim Abrar?
Present, sir.
So Jarin Tasnim Ridi was present.
Yeah, I've given your present Ridi. Okay. Chaudhary Blossom Ibn Razak?
Present, sir.
Fardin Fayaz?
Present, sir.
Labib Muntasir?
Present, sir.
Ehsanul Haq?
Present, sir.
Tanbir Chaudhary?
Present, sir.
Aryan Bashir?
Present, sir.
Iftikhar Zaman Ifti?
Present, sir.
Naim Mubashir Monim? Monim? Labiba Nawar? Labiba Nawar? Qazi Samin Yasir Alam?
Present, sir.
Awaja Ishma Marian? Awaja Ishma Marian? Sakif Kaisar?
Present, sir.
Radib bin Kabir?
Present, sir.
Yusuf Ibn Kamal Niloy?
Present, sir.
Miftul Alam Siam? Miftul Alam Siam?
Sir, he is absent.
Mehdi Ahmed, okay, you're present. Abdullah?
Present, sir.
Mustabshir Ibn Amin? Mustabshir? Muhtasim? Okay. Okay. Mohtasimul Doha,
Present, sir.
Maruf Ahmed, Maruf, Samnun Asfar,
Present, sir.
Ramis Zaman Audhi,
Present, sir.
Mahajabin Tabassum,
Present, sir.
Mohammad Tamim Sarkar, you're there.
Present, sir.
Sadia Sultana.
Sir, she was present, but her electricity just went off.
Okay, I shall get the present. Shadman Nahian, absent. Merin Tazin, absent. Sadiq Salman.
Present, sir.
Mutlashim Kamal Dihan.
Present, sir.
Mosammad Jannatul Samaruk.
Present, sir.
Mushfiqur Rahman. Saima Situl Muna. She sent me a mail saying she is traveling today anyways. Okay. Shajid Hossain.
Present, sir.
9F Siddiqui. 9, I think 9 wrote in the chat, right? Okay. Muna is there actually. And 9 is there. Tanvir Hossain Dihan.
Present, sir.
Shamia Sharmin Tivana. Shoaib bin Hassan.
Present, sir.
Tarif Safwan Haq.
Present, sir.
Safwan Sakib. Sayan Ilham.
Present, sir.
Tamim Ahmed.
Present, sir.
Tanvir Ahmed Tanmoy.
Present, sir.
Abbe Alum Saad is absent. Tanvir Hassan Ananto.
He wrote it in the chat.
Munzer Mahmood.
Yes, sir. Present, sir.
Okay. Amina.
Present, sir.
Wasalutufi Sebania. Arsalan.
Present, sir.
Idris Farash.
Present, sir.
Penda Koleveli. Penda also didn't get her script for the meet. That's a problem. Abdul Halim Hadoroni. Alom Alzin. Ibrahim Ahmed, Ibrahim Muhammad.
Present, sir.
Ishmam, I have given your present, I think. I'll check.
Sir,
roll
41
number
present.
45.
Yeah, 41, I've given your present. Suraya Nora. Okay. Elma, what were you saying?
Sir, roll number 45. Shamia Sharmin Tivana is also affected with corona. That's why she said she won't be able to join the classes for this week.
You can come back. It's fine. She like, yeah, that's fine.
Okay, sir.
Una, Ishmam, and then on to 153. Yeah, Ananta, I've given your present. Nahin. So, okay. That's all for today's class. Like, if you have written something in the chat as a question for the class and I haven't seen it, kindly like remember to like remind me or someone else of you. And about like if P and Q both are pointers, you cannot like, I have already answered it. You cannot write like P is equal to N Q directly because types don't match. Like and Q is like address to pointer variable and P is a pointer, so they'll cause mismatch. If your P is a pointer to pointer, then it will work. Otherwise, it will not work. Anyways, thank you for today's class. Okay, Tanvir, Tanmoy, did you get your answer?
Yes, I got it, sir. I have understood it.
Okay.
Thank you, sir.
Thank you. And thank you for today's class. I have actually checked your mid script. Inshallah, I can give you the result next week. Remember about the quiz next week, and today's lab is a bit early. Other than that, thank you, everyone.
Assalamu alaikum, sir.
Walaikum assalam.